All right, we're at lesson 1.6, and the topic today is solving systems of equations. Today we're going to be dealing with systems of two equations. Really close to now, not too far away, we're going to be dealing with systems in three equations. That's something that you haven't dealt with before. But first we need to make sure we're good with the two equations and two variables. And there's three methods that we're going to focus on today for solving these. We're going to first solve them using the graphing method, or my objective says solving graphically. And then we're going to look at solving algebraically, which means the substitution method and the elimination method. So I'm hoping that this is just going to be a review, a little refresher. We're going to try to fly through these examples and get you ready for tonight's assignment. So when we solve by graphing, the goal is to sketch the graph of each of these linear equations. And if there is a solution, it'll be where they intersect. That point of intersection is the solution to the system. So let's just go through our normal routine. For the blue equation, I'm going to solve it for y. So I can look at it in slope-intercept form. 5 is the y-intercept. Negative 2 is the slope, so I start at positive 5, and I count a negative 2 slope as up 2, left 1, or down 2, right 1. And you'll definitely want to use a ruler for these because we need to be precise. We need to know exactly if they cross, where they cross. Okay, so I'll just match up blue equation and blue line. All right, now let's work on the red equation. Solving it for y, that just means add x to both sides. It has a y-intercept of 2 and a slope of positive 1. So from the y-intercept, I go up 1, right 1, and grab our straight edge. And you want to draw these lines long enough to give them a chance to intersect. Obviously, these do cross, and where they cross represents the solution to the system. So when you do these problems tonight on the homework, I need for you to tell me on your graph paper the ordered pair of where they cross. So the solution is going to be x is 1, y is 3. So just so you'll know, the solution to a system means that when I find x and y, I should be able to plug those numbers in for x and y. And not only should the blue equation be true as a result, but the red also. A true solution to a system will make both of these equations balance when we substitute in for x and y. So you can always check and make sure that you're right. If I let x be 1, and y be 3, does the blue left side equal the right side? 2 plus 3 equals 5. It checks out. If I let x be 1 and y be 3, that's negative 1 plus 3. Does that equal 2? Yes, and so I've just proven, I've given myself some confidence that this has to be the solution because it made both of these work. It made both of them true. All right, let's try another one. So the routine, again, is we typically write these in slope-intercept form. So I'm going to just work horizontally here. I'm going to subtract x. And then I'm going to divide by 3 or multiply by negative 3, however you want to think of it. Okay, so let's go ahead and graph the red equation. I've got a y-intercept this time of 2/3. So I'm going to approximate where 2/3 is, just below positive 1. And then from there, we're going to count a slope of negative 1/3. So I'm going to go up 1, left 3. Or if you would rather, you could go down 1 and right 3. And grab your straight edge. And we're going to connect those. Okay, now let's work on the blue. Subtracting 3x from both sides. Multiplying by 1/3 or dividing by 3, however you want to look at it. So here's my slope-intercept form. I have a y-intercept of -2. And from there, I'm going to count a slope of -1. Up 1, left 1. And we'll sketch the blue line. Notice where they cross, and the point of intersection represents the solution. The x-coordinate is the solution, of course, for x, y for y. So it looks like they cross at -4x, +2 for the y. Okay, any questions about those first two examples? We're going to take a look at a couple of kind of unusual examples. Let's start with our example letter C. Let's just go through our normal routine, solve for y. So I'm going to subtract 4x from both sides. Divide by 8 on both sides. And if I divide by 8, I'm going to kind of run through this pretty quickly, but dividing by 8 makes this -1/2x. -4/8. And it makes this +3/2. 12/8 reduces to 3/2. All right, so let's just go ahead and graph this now, this blue line. That's a 1.5 y-intercept. 1.5. So here's 1.5 on the y. With a -1/2 slope, so up 1, left 2, or down 1, right 2. And connect them. And now we'll work on the red. I'm going to subtract x from both sides. And we've talked about this when we were writing linear equations. What do we know about two equations that have the same slope and different y-intercepts? What's true about those lines? If they have the same slope and they cross the y-axis at different places, what must be true about those two lines? Two lines that have the same slope are called parallel. Good job. So let's go ahead and draw it, and then we'll come to a conclusion on what the solution is. Actually, if they don't cross, there isn't a solution. But we're going to go ahead and draw the two lines. So here's -1.5 y-intercept with a -1/2 slope. Up 1, left 2. So we're showing that these two lines will never cross. And if they never cross, then don't just leave your answer like this. Go ahead and interpret it. There is no solution. So 3 things can happen when you're solving systems. We've looked at 2 things. There is a one solution, one x and one y. 2 lines cross at a definite point. There is the no solution where you have 2 parallel lines that never cross. Well, here's the third possibility. The blue is already solved for y for us, so let's go ahead and work on solving the red for y. In solving for y, what do you notice? It's the same, not only the same slope, but the same y-intercept. It's the same line. We didn't realize it at first, but it's really just the same equation written twice. It's like the line graphed on top of itself, if you want to think of it that way. Well, let's just go ahead and draw that one line, y-intercept 3, slope of negative 1/4, up 1, left 4, or down 1, right 4. Okay, so there's the line, and here's how we interpret this situation. Any ordered pair that we could find that is on this particular line is a solution to this system. That means 0, 3. That means 4, 2. That means, what is that, 12, 0. And there's more than I could ever count because where's this line going? It's going forever right. We call that positive infinity. It's going forever left. We call that negative infinity. It's never going to stop. There are more ordered pairs on this line than we could ever count. So the way we interpret this situation is there is an infinite number of solutions. So one of 3 things will happen. The lines cross, one solution. They never cross, no solution. It's just the same line written in 2 different ways, but when we simplify, we figure out it's really just the same line. This is the infinite number of solutions. All the ordered pairs on that line make the system true. Okay, questions before we move on? That's method number 1. That's the graphing method. Now let's look at solving algebraically. And that's going to involve, first of all, substitution. Substitution says this. Solve for a variable in these systems that you're dealing with. They're all 2 variable systems. Well, substitution says solve for one of the variables in one of the equations and then replace that variable in the other equation. Well, this first example is really simple. And it's really nice for using the substitution method because one of the variables is already given to us. It's already solved for. They tell us one of the equations is that D is 10. Well, substitution says if D is 10, then you can replace the D in the other equation with 10. And you can solve for C. So it looks like this. 4C plus 3 times 10. So I'm just going to put 30 equals 6. And now we just go through the routine of solving for C. I'm going to subtract 30 from both sides. And C is negative 6. So I usually get this question when the variables are not x and y. We know what x and y coordinates look like. What about variables C and D? What do those look like in ordered pairs? Well, just think alphabetically. C comes before D. So the ordered pair answer here would be negative 6, 10. Okay, here's another substitution method problem. So let me give you a tip when it comes to substitution. Notice that I really have 4 choices here for variables that I could solve for. There's 2 x's and there's 2 y's. total of 4 choices. But there's one best choice in this problem. The best choice, if it happens, and it does in this case, is choosing the variable that has a coefficient of 1. Because there are fewer steps involved in solving for that variable. So I'm going to choose to solve for x in the bottom equation, because I can do that in one step. All I have to do is add 3y to both sides, and this equation is solved for x. So once again, substitution says solve for a variable. Okay, I just did that. And now replace that variable in the other equation. So in the top equation, I'm going to replace x with 3y plus 3. Looks like this. Negative 2, and now in place of x, I'm going to substitute 3y plus 3. And then the rest of this just gets written just like it shows. Distributive property. Combine like terms. Add 6 to both sides. Don't ever solve for a negative variable. Always make it positive. You've got 2 ways of thinking about that. You can either divide or multiply both sides by negative 1. Doesn't really matter which one you choose, but the bottom line is that positive y is going to equal negative 4. All right, so we have half of our answer. We have the y of the ordered pair. How are we going to find the x? Well, you're really not wrong in going back to either one of these equations, but it makes sense to go to this equation that's already set up for x. Just replace y with negative 4 in this equation that's already solved for x, and then that will very quickly give us the value of x. So it looks like this. X equals 3 times negative 4 plus 3. Negative 12 plus 3, x is negative 9. That's our final answer. X is negative 9, y is negative 4. Questions so far? Okay, let's try one more substitution. Do you see a variable that looks like would be the best? There's not really a wrong choice, but many times there's a best choice. What would you say is the best choice of these 4? Okay, the top equation in which variable, x or y? Y. I would agree, because there's fewer steps involved, and we can avoid fractions. If you can stay away from fractions, most people would say, yeah, help me stay away from fractions. And that will help us stay away from fractions if we solve for y in the top. So I'm going to subtract 3x. And again, you never solve for negative anything, but multiply or divide by negative 1 forces this. Okay, substitution says solve for a variable. We just did that. We solved for y. And now replace that variable in the other equation. We're going to put 3x in for y in the bottom equation. 4x plus 3 times 3x is 26. 13x is 26. X is 2. So we got half of our answer. It's going to be an ordered pair. X is 2. I already have this equation set up for y. All I have to do is drop 2 in for x. 3 times 2 is 6. So my answer is x is 2, y is 6. Okay, I've got one more substitution, and then we'll take a look at elimination. Again, I've got 4 choices. None of them are necessarily wrong, but there is one that's best. The best option is to solve for x on the top. And here's why. If I solve for x, that means I'm going to be adding 6y to both sides. And now I'm going to be dividing by 3. Do you notice that 3 goes into everything and I don't have any fractions? All of these other choices, if you solve for a variable, you're going to end up with fractions. You're going to have to use the distributive property with fractions. It's not necessarily terrible, but it may not be the best move for most people. Okay, so I've solved for x, and once again, I know I'm repeating myself, but substitution says solve for a variable, and then replace that variable in the other equation. So we're going to replace x in the other equation with 2y minus 2. Distributive property, 8y minus 8 minus 5y. Combine like terms. 3y is 12, y is 4. Okay, so half of our answer is determined. I already have this equation over here solved for x, so that's what I'm going to use. I'm going to replace y with 4. 2 times 4 is 8. 8 minus 2 is 6. And that's my answer. Okay, we've looked at graphing. We've looked at substitution. Now let's close this out with elimination. Elimination says solve this system by forcing one of these variables to cancel when you add or subtract like terms. This system is set up perfectly for elimination, because if I add the like terms together, just adding vertically, y will automatically eliminate. Negative 2y plus 2y is 0. Elimination is another word for cancel. So since it took addition to eliminate y, I'm going to have to add all the way across. 3x plus 2x is 5x. The y's are gone. That's just 0. 14 plus 6 is 20. I got my first variable. X is 4. So we know what half of the answer is. And now it doesn't matter which of these equations you go back to and substitute for x. You'll be right either way. I'm going to go with the bottom one. 2 times 4 plus 2y is 6. That's 8 plus 2y. Subtract 8 from both sides. And we get our y value is negative 1. So that is a problem, a system that's set up ideally for elimination. Okay, this one doesn't just have a variable that automatically eliminates with addition or subtraction. But if you notice, if I just multiplied the bottom equation by negative 3, then I would be in good shape to eliminate y. So in this case, I'm only going to have to multiply one of the equations by something in order to force a variable to cancel. And it would be okay if you multiplied by positive 3. That would just change the operation that you would use. Okay? So I'm not doing anything to the top equation. But the bottom equation is going to become 21x minus 6y is negative 93. Okay, so identify what's it going to take, addition or subtraction, to eliminate y. Obviously they're opposites, so I'm going to have to add. So that means I've got to add all the way across. 10 plus 21 is 31x. The y's cancel. 0 plus negative 93 is negative 93. And so x is negative 3. And so now we're back to what we did before. You can choose either one of these original green equations to plug negative 3 in for x. I'm going to go with the top one. So this is negative 30. Add 30 to both sides. and you get y is 5. So my answer for this problem, letter B, is x is negative 3, y is 5. Okay, so we'll move on to our example C, and in this case we're still supposed to do the elimination method, but neither one of these variables just automatically eliminate with addition or subtraction. And it's going to require more than just multiplying by one equation in this case. So we really have an option. If we wanted to eliminate m, we could multiply the top equation by 3 and the bottom equation by 2, or negative 2, negative 3. In this case, multiplying by positives means I would have to subtract to eliminate m. I could also have this as an option. I could multiply the top equation by 5, the bottom equation by 4, or again, you could make one of these negative, create opposites where you would have to add. It really doesn't matter which direction you choose. I'm going to go with multiplying and eliminating m by using 3 on the top, multiplied all the way across, 2 on the bottom. And I'm setting this up to where I would subtract to eliminate m. So after multiplying, I'm going to get 6m plus 12n is negative 12. And on the bottom, it's 6m plus 10n equals negative 6. Okay, again, these are like terms, so subtraction will make them cancel or eliminate. The m's are gone. 12 minus 10 is 2n. And negative 12 minus negative 6, that's another way of saying addition. Negative 12 plus 6 is negative 6. So n is negative 3. So our solution will be the ordered pair m, n. Just remember m comes before n in the alphabet. So negative 3 will be the second of the two numbers in the ordered pair. So to find m, I just replace either of these n's with negative 3. And I'm just going to go to the top equation. 2m plus 4 times negative 3 is negative 4. 2m minus 12. 2m is 8. If you add 12 to both sides, m is 4. And so that means my final answer is m is 4 and n is 3. Okay, and that's the assignment. You've got some graphing, some elimination, and some substitution. And let me know if you have any questions.